Day 289 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again. Another day, another LeetCode problem. You already know how we do. And today we have question number 63, unique paths 2. The difficulty level is medium, but don't worry because we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, comment, and subscribe. And if you need any new Apple AirPods, go ahead and check out that link in the description and get you some. Now let's see what the question says. Question says, you are given an n by n integer array grid. There is a robot initially located at the top left corner, i.e. grid 0, 0. The robot tries to move to the bottom right corner, i.e. grid n-1 and n-1. The robot can only move either down or right at any point in time. An obstacle and space are marked as 1 or 0, respectively, in the grid. A path that the robot takes cannot include any square that is an obstacle. Return the number of possible unique paths that the robot can take to reach the bottom right corner. The test cases are generated so that the answer will be less than or equal to 2 times 10 to the 9th power. So, now that we've read the question, let's go ahead and take a look at these examples so we can make sure that we know what it is that they want us to do exactly, right? So in example 1, we have the input equals obstacle grid equals an n by n grid or 2D array, right? With the first row being 0, 0, 0, second row being 0, 1, 0, and third row being 0, 0, 0. Now remember, each one of these zeros just represents an open space. So that means that there are no obstacles in row 1. Then this represents, remember, this is row 1, excuse me, y'all. This is row 1, this is row 2, and this is row 3. Now remember, we have no obstacles, or if you see, we have no obstacles in row 1 and row 3. That's this row and this row. But in row 2, we have an obstacle, and it's marked with a 1 right here. The 1 lets us know that there's an obstacle right here. And as you can see in the picture, we have an obstacle right there. So now the output is 2. Explanation says there is one obstacle in the middle of the 3 by 3 grid above. There are only 2 ways to reach the bottom right corner. We could go right, right, down, down, which means the robot will go right, right, down, down, and then they reach the bottom right corner. Or the robot could go down, down, right, right. And as you can see, go down, down, right, right. And those are the only 2 unique paths that the robot can take to get from this corner to this corner where the star is. The star is not an obstacle. The star is just the end goal where we're trying to reach. And since there are only 2 unique different ways he could get there, then we're going to return 2 as our output, right? He could either go this way, that's one path, or he could go this way, that's the second path. And there are only 2 paths he can take. So let's go ahead and look at example 1 where the grid is a little smaller, but it's the same principles. In example 2, we have the input obstacle grid equals n by n matrix grid with the first row being 0, 1, second row being 0, 0. Output is 1. As you can see, once again, this represents row 1 and this represents row 2. And as you can see in row 1, we have an obstacle right here, which is right here. Right, so there's only one way he could go to get from here to here, meaning he has to go down 1 and to the right 1. Boom, and that's his only path he can take. And that's why the output is 1, because there's only one path. So now that we understand the question, let's get into the fun part, the actual solution. So the first thing we're gonna do is we need to ensure the grid is not empty, and if it is, we can return 0 because that means 0 paths exist. So in order to do that, we can say, oh, sorry, y'all. We can say guard, exclamation point, obstacle, obstacle grid. My bad, it's right here. Had to get my spelling right. Obstacle grid dot is empty, else we could just return 0, because if it's empty, then there's no paths. Next, we need to create our dynamic programming array, and we'll just initialize it to start. So in order to do that, we'll just say declare variable. We could call it dp, and we'll say set it equal to a 2D array of integers. So we can say square brackets, put the int inside for integers, Then we're going to say, come outside of that, open up the parentheses, and we're going to say repeating, colon, then it's going to be an array of integers. So square bracket, int, come outside of that, and we're going to say open up some more parentheses, and we're going to say repeating, colon, then we're going to say -1, then we're going to say comma and count, colon, obstacle, my bad, y'all, it's the spelling, obstacle, grid, square bracket 0, come outside the square brackets, we're going to say dot count. Then we're going to come outside these parentheses, but still inside the other parentheses, we're going to say comma, and we're going to say count. Then we're going to say colon, obstacle, grid, dot count, just like that. Boom. Now we need to we're going to create a recursive function which is going to help us to calculate the unique paths given, right? Or to a given cell. So we're going to say for our recursion inside this main function, this recursion we're going to create a new function inside of the main function, and we're going to say func. We could just call it calc. We'll open up the parentheses. We're going to say underscore r colon. That's going to be an integer. That r is for row. Then we're going to say underscore c colon. That's going to be an integer as well. The c is for column. Then it's going to return an integer. Then we're going to open up our brackets. Now, if it's out of bounds or there's an obstacle in the current cell, we're just going to return 0. So we're going to say if r is less than 0, comma, or excuse me, not comma, we're going to say or, so 2 lines, or c is less than 0, 2 lines again, or obstacle grid, square bracket r, square bracket c is equal to 1, because if it's equal to 1, that means there is an obstacle right there. We could just return 0. Boom. Now, if we reach the start cell, then that means there's only one way to get there. So we could just say, handle that. We could say if r is equal to 0 and 2 and signs, c is equal to 0, then we could just come right here, open up the brackets, and we could just return 1. Boom. Now, if we've already computed the value for the cell, then we can just return it. So we could just say if dp square bracket r, come outside the square bracket, then we're going to say square bracket c, come outside of that, does exclamation point equal, so it does not equal -1, then we could just say, open up the brackets, we could say return dp square bracket r, come out the square bracket, open up more square brackets, and say square bracket c. So return dp square bracket r, square bracket c. Otherwise, we can just compute the number of ways by adding the paths from the top to the left and left cells. So in order to do that, we can just come right here. Not right here, but we could come right here and we say dp square bracket r, come outside that square bracket, open more square brackets, and say, not dpr, should just be dp, sorry. Square bracket r, square bracket c. We can set that equal to calc. This is where we're going to use some recursion. We're going to say r minus 1. Make sure it's equal white space, -1, not -1. Then we're going to say comma c. Then we'll come outside of those parentheses and we're going to say plus calc, open up the parentheses, r comma c -1, just like that. And then we could just return, come underneath that, and we could just return dp square bracket r, square bracket c. Now we need to start the recursion. So in order to start the recursion, we could just come right here and we can say return calc, open up the parentheses, we can say obstacle grid dot count -1 equal white space, comma, obstacle grid square bracket 0 dot count minus 1. Now, that should be all she wrote, y'all. Let's go ahead and run it. Hopefully it runs properly. And it's accepted, y'all. So let's go ahead and submit it. Make sure it stays accepted after we have submitted it. Let's see, and it's accepted, y'all. And look at those numbers. 0 milliseconds beats 100% of users with Swift. Y'all all know those are the numbers I like to see, I love to see. So with that being said, y'all, make sure you get one more look at the code. And I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.